Okay, next up, we would like to we have f of x is equal to 2x plus 2. How do we find the inverse of the function evaluated at 4? And so let's understand what's actually happening with this question. And so we know that a function relates two groups together. And so a function will tell me that if I have specific values in this x pool, they will give me a specific value in this y pool. That's how I relate to different pools in a sense. And so like on Desmos and in our graphs, we're relating two perpendicular vectors. And so now in this case, f of x would be going forward. I have x values, they give me y values. Now the question here is, what about if I have y values and I want to get back? So what if I have y is equal to 6 and I want to find out what values of x gave me that 6? Now we create what is called the inverse of the function, and that is what will help me get back. And so how to do this mathematically is we actually reflect this in the line x is equal to y. And so with our function, f of x is equal to y, which is equal to 2x plus 2, you're going to isolate x. So this will become y minus 2 over 2 is equal to x. And then what you're going to do is you will now call this x the inverse, and this y you'll label x. And that's just because of we tend to call x our input and y our output. And so since we're going backwards, our input, yes, it is y, but we like to call our input x. So we'll still call it x, and we'll call our output f minus 1x in order to distinguish the two. And so I get that the inverse function is x minus 2 over 2. And so for our question, we want this evaluated at 4. And this will give us 4 minus 2 over 2. This is 2 over 2, 1. So what I have just done is basically I'm saying if the function is 2x plus 2, and I give you the output of 4, what x value did I have to put in to get that? And so if y is equal to 4 is what this question is asking, what x value would I have to put in? So 2x plus 2 over 2, and if you go and you find the x value, you'll find that it's actually 1. So this will become 8 is equal to 2x plus 2. Sorry, yeah, so we get 4 is equal to 2x plus 2. This will become 4 minus 2 is equal to 2x over 2 over 2. And so you see, I'm putting it in a way where I get x is equal to 4 minus 2 over 2. So my input, so my y in a sense, and this will give me 1. And that's what all of this was telling us, is that if the output was 4, what is the x value that I put in? And so it's just jumping in between these two worlds that we've created that we can only relate with our function. And that's it for this question. All right, let me just explain that a little further. And additionally, since, as I mentioned, we're reflecting in the line y is equal to x here, graphically, it's going to look exactly like that, like I'm reflecting in the line y is equal to x. And so for my function, I have 2x plus 2. If I draw the line y is equal to x, and then I put in what I found as my inverse function, so x minus 2 over 2, I will see that these two are symmetrical about this line, and it's because I reflected them in this line. And so this tells me that this is the correct inverse of 2x plus 2. A couple other more distinct examples would be, let's say I have x plus 4 squared Now when I go about finding the inverse really quickly, so if I have y is equal to x plus 4 squared, root y is equal to x plus 4, x is equal to root y minus 4. So f minus 1, x is equal to root x minus 4. So let's go ahead and just put that in. So x to the power of 0.5 minus 4. So here I can see that yes, a little bit of information is destroyed, and that's just because of the nature of the function. But if I draw the line here, y is equal to x, I see that this is simply the reflection of this in this line. And so because of the reflection being at a 45-degree angle, it's going to flip it over, and it's going to, rather than being vertical and upright, it's going to become horizontal. And that's it for this question.